Old town quartiers like here in Gubbio, Italy, are a source of local pride and an irresistible tourist attraction. But are we in danger of losing this historic heritage to climate change? The 14th century Palazzo del Console is one of Gubbio's most iconic buildings, hosting art and archaeological exhibitions. But the cracks appearing in the stone walls are raising concern that the ground under the Palazzo may be shifting. This could be caused by climate change, as rains are becoming stronger and more frequent. The city takes this threat very seriously.
Gubbio is a city made of stone. It's an element that's most precious to us. We have to keep it under control.
Scientists from HERACLES, a European research project, are studying the effects of climate change on ancient monuments. Their methods range from using satellites that monitor ground shifting to taking samplings of walls, like this test with a pressure-sensitive drilling tool.
First of all, this sampling shows how hard the stone is. After this, a chemical analysis of the drilling residue will reveal the mineralogical composition of this stone. It will show possible products of erosion, like soluble salts.
Gubbio knows very well how rain can bring down stone walls. In the past, parts of the ancient city's defence perimeter have already collapsed under the weight of shifting ground. Rains have weakened the mortar, and stones are falling out. What remains of the city is now carefully monitored.
Over
the past 3 years, we had a lot of extreme weather. The precipitation was much above average. This is affecting the wall structures that we need to maintain.
Gubbio isn't the only place where scientists are working to understand the climate threat. Climatic fluctuations are particularly menacing in coastal towns, rich with monuments such as Heracles, the Venetian fortress in Crete. For a deeper understanding of what's going on, let's join scientists in the Mediterranean Sea. The waves hitting the 16th century fortress are constantly eroding its walls. Changing climate shifts the wind direction and the pattern of waves. What does this mean for stone structures? Some clues may be found at the seafloor. These researchers are using sonar to find out how the sea is affecting stones underwater.
This sonar allows us to see what's happening on the sea floor. On the scans, we can clearly see cavities in underwater fortifications. Through repeated surveys of this area, we can observe how these cavities are evolving with time. This way, we can keep tabs on the erosion.
At the seafloor, the researchers have installed sensors that are continuously recording water temperature and wave height. Twice a year, scientists dive to retrieve the data from these sensors.
We need this data for our digital model to see how waves affect the Heracles fortress. We need to know the wave energy the fortress receives. By combining this with past measurements, we can make short and long-term projections and see how this is evolving due to the effects of climate change.
After the data has been copied, researchers place the sensors back on the seafloor for another 6 months of monitoring. Some of the effects can be detected inside the fortress. This instrument flashes a powerful laser on the wall's surface, turning its particles into plasma that can be chemically analysed.
The sodium chloride, the salt, accumulated in the surface. This is one type of accumulation from the sea. But also the water penetrates the gold and changes the chemical structure of the rock and this also affects significantly the monument.
Local authorities use the data collected by scientists to get a better idea of how to maintain this site. There are concerns that with climate change, old stone buildings will degrade faster, making their upkeep more expensive.
We've already conducted a large restoration campaign here. Our aim is to keep monitoring the building to see if and when more measures will be needed. Our ultimate goal is to find a way to protect this monument for the next 500 years.
The Knossos Palace, site of the Minotaur's Labyrinth, was partially restored 100 years ago with reinforced concrete. Climate extremes have weakened the cement, causing the iron to rust. To preserve this site, new types of cement and mortar are needed.
Our research project will help to create new materials and make them available to restorers, so that we'll finally have a solution suited for this particular monument. This will help us to better protect our heritage.
Scientists have developed a new mortar adding nano and microparticles that improve weather resistance. And there's a new cement, which is similar to the one used originally, but less porous, so air can't penetrate it as easily.
These practical results can be used directly at this archaeological site, one of the most important, most significant in Europe, the site of the first European civilization in the Mediterranean basin.
Europea del bacino mediterraneo.
From planetary-scale climatic changes to microscopic specks of dust, scientists are fighting battles on many fronts to defend the heritage of our art and history.